So epistasis, this word you do not need to actually remember the name epistasis, but if a question come out, you need to put it, you can use it. But basically it's a gene interaction. So it means that one gene actually affect another gene. Okay, so we look at what actually happened here. So epistasis always involve two genes. It must involve two genes. Okay, and most of the times, or in general, these two genes, they are located on different chromosomes generally. Then you can see the effect. Okay, different chromosome. So it means that they are not linked, basically, okay, not linked. So you have gone through my notes yesterday. We talked about the autosomal linkage. So this one is nothing to do with autosomal linkage. There are two genes, they are interacting together. Okay? They interact together to give us the final expression or final phenotypes. Okay, so in epistasis, the phenotypes expressions of a gene on one locus, they can alter, okay, they can change. Okay? They can alter or change the genes at a second locus. So for example, if you look at this Labrador retrieval, so they do have the allele that control their coat color. So black coat color is dominant, it's dominant compared to the brown. So if you use the symbols here, big B will code for the black coat, small b will code for the brown coat. But whether it's black or brown, this one have to be determined by a second gene, which determine whether the color can be deposited or not. Can I see that? Okay, I can produce color, I can produce black color, can produce brown color, but it depends on the second gene to determine whether the pigmentations can be deposited or not. So this pigment whether can stay on the fur or not. So it depends on this gene that have two allele. One is the big E allele, result in a deposition. Can I see that? So, but if the labs, okay, or this Labrador retrieval, they have a recessive for a second locus. So it means that small e, then we don't care about whether, their dominant allele or recessive allele, they won't get the black or brown color, they will get the yellow color, which is no deposition. Can I see that? Regardless of the genotype at the black or brown locus. So if we look at this, we will be able to figure out now. If you want to have a Labrador retrieval, okay, with three genotypes. So we're going to three phenotypes. We're going to have black, we're going to brown, we're going to have yellow. So in order to get black color, so it means that they must have at least one dominant allele for B. Second one is totally free. It can be a dominant allele, it can be a recessive allele, because big B allele going to mask the effects of the recessive allele. But in order to get the black color to be deposited, I need to have the E allele to be expressed. So this is the general genotype for the black color. If brown color, then it cannot have the big B, cannot. It must have a small b, but we want the brown color to be deposited. So it must be big E. So the last one actually can be big E or small e, doesn't matter, as long as we have one big E allele there. How about yellow? Yellow, I don't care what color in front. Basically, the last two must be small e, because no depositions of the color. So can you see that now two genes actually work together to show the phenotypes? In this case, you won't get the fourth phenotypes. You won't have 9331 anymore. So that's why it's a dihybrid cross. You won't get 9331. What you're going to get here is a different ratio. Okay. So therefore, we say that the pigment depositions, the gene E, to be epistatic to the gene that code for the coat color, means that the deposition will have a final say what kind of the color, okay, whether can deposit or not. The control, the control. So in these questions, say figure 14.31 show the three color codes of the Labrador retrieval, and from here we need to list. This question asked before. We need to list down what are the possible genotypes. So black, just now I say that it must have one big B, one big E, definitely. Okay, the rest are free for you to fill in. Brown, it must be a small b, big E. The last one free for you to fill out. Yellow, outside. Don't care about what is their genotype for the code color, but the last two must be small e. Okay, so based on this, down these are the possible genotypes. Okay, a question may ask you to list out all the possible genotypes. So therefore, you must know the concept of this epistasis. Okay, so it means that here, if you're still confused why I put a blank, this blank you can fill it with big B or small b. This one can fill in with small e. That's it. Big E, small e. Okay, so this one it can be either big E or small e. This one it can be big B, okay, or small b. Doesn't matter already. Okay. So we look at this epistasis, how it takes place. So they are not linked gene. They are not linked gene. So we do according to the dihybrid. We still follow the dihybrid, where independent assortments take place. Okay, where independent assortments take place. So quick revisions, okay, like what we have always talked about this. So first you have the genotypes. Okay, so both of them black. So black color codes, but heterozygous. I draw the genetic diagram to show the probable results of mating between two black Labrador retrieval of genotypes big B, small b, big E, small e. So basically they are heterozygous. So heterozygous independent assortment take place. Always remember gamete genotype, you must have the probability. Then you must circle the gamete genotype. Okay, this is a requirement. Then after that, you put it in this diagram. So you can see that, okay, so in terms of color, as long as you have see this, right? Big E color can be deposited. So therefore, you check back the first one. So this one is black. Can I see that? So this one also black, black color, black color. Okay, you follow this one, black color, black. Okay, but you look at this. Small e, small e. Okay, small e, small e, small e, small e. Hey, why I put the wrong ones? Okay, small e, small e. So means that no deposition, no deposition. So definitely they are yellow color. Yellow, yellow, yellow. Can I see that? Okay, and also here. Okay, yellow. Now the last one. You look at this. Yes, got depositions, but small b. So small b indicate what? They are brown color. So according to this, you can see that you no longer get 9331, but you get the black coat to brown coat to yellow coat in a ratio of 9:3:4. Again, it doesn't follow the Mendel dihybrid cross anymore. In this case, you can see that you get a 9:3 to 3 to 4. Okay, so do you guys have any questions regarding to this phenotypic ratio? This one should be F2, phenotypic ratio. Okay, so if no questions, then I stop here for recording. Then I want to break it to few